Hello, I'm Damien Dalton, Senior Lecturer in Computer Science here in University College Dublin and CEO of Strategear. Over the next few minutes I hope to explain to you the environmental impact of global IT activity in terms of the energy that is consumed and the carbon emissions that it injects into the atmosphere. It will highlight the social and economic imperative we now face to make all our computer activity more sustainable and greener in the world that we share. More sustainable and greener use of our IT assets is better for our environment and leads to a reduction in capital expenditure, operating costs and real estate requirements in data centres and server rooms. Both the environment and the business are clear winners. Let's go now to a data centre to see some of the issues. Well, here we are probably in what is typical of the normal server room or data centre in your institute. Of course, to make these improvements requires practical and effective energy measurement and management of all computing devices and resources. And unfortunately, many data center systems fail on both of these counts. Let's look at the problem. First of all, as you can see, it's rather tight for space and a noisy environment. If you want to install physical meters, it requires retrofitting and cabling in an area that's already like a spaghetti jungle. Practically all servers are in production, so you can't afford any downtime, and accidentally disconnecting a cable can have very serious and dire consequences. Even if these weren't problems, conventional physical metering systems don't supply some of the really important and incisive energy information in our data center because they don't have the necessary level of energy resolution.
Today, servers are virtualized and shared by different users, cost centers, and services. For effective data center management, we must provide business object information, such as the following: what services, apps, systems, or departments are consuming energy and by how much. We need to establish cost centers with energy and carbon budgets. And also we need accurate cost-benefit analysis for all investments.
This requires more than just physical power measurement. We need to measure power at the virtual machine, application, service, and user level. And importantly, it must be done easily and with zero impact in performance on the existing infrastructure. It demands a new innovative approach, a new technology. At Strategear, we have that solution, Papillon. You could install your entire Papillon energy management system from a simple memory stick. With Papillon, you have an accurate energy metering and management system without any physical meters. Metering with no cabling or downtime. Metering that goes beyond just the physical, giving you energy information in a business context that you understand.
We live in a global information age thanks to the internet. An age where there is instant communication, a world without frontiers or barriers, which we can enter simply with a mobile phone, a laptop, or perhaps even a watch. This is the world of the cloud, where Google processes in a day the same amount of data as in 1,000 US Congress libraries. No longer are humans solely the generators of data and information. In the cloud, practically any object, from medical devices to clothes, can now gather data and release it to the internet. We have what is termed the Internet of Things, creating the era of big data. Central to the cloud is the data center. These are modern air-conditioned warehouses containing thousands, indeed in some cases millions of servers, processing relentlessly the queries, the commerce, and the entertainment of the internet. Obedient servants in these 21st century cathedrals. However, despite the undoubted benefits of the cloud, there are associated substantial economic, social, and environmental costs and challenges. The three pillars of sustainability. With the growth of information technology, the environmental impact is already substantial and certain to worsen if we don't change our attitudes or practices. In 2015, European data centers will consume 100 terawatt-hours of electricity, the same energy demand as 15 million homes or the entire electricity consumption of Portugal. By 2020, it is predicted 25% of Europe's electricity production will be consumed by ICT equipment, potentially crippling the electricity grid. Worldwide data centers will produce 330 million tons of carbon dioxide in 2015, equivalent to the carbon footprint of the entire global airline industry, or the national carbon emissions of Argentina and Netherlands combined. And without effective energy management, it is anticipated that global data center carbon emissions will quadruple by 2020. Despite the technical sophistication of data centers, most are highly inefficient. In the average data center, 30% of servers are idle for 97% of the time. This translates into $30 billion of wasted capital investment worldwide and a 30% overall waste of global data center energy usage. Yet, just as technology can create problems, technology can solve them. Sustainable solutions imply that sustainable energy sources are used whenever possible, and it also means using energy management systems that reduce energy consumption to a minimally feasible amount. Numerous studies have shown that with proper energy management tools and adequate training of key personnel, data centers can reduce their energy consumption by 40%.
The maximum you can only manage what you can measure is central to any approach that intends to reduce the energy costs and increase the productivity of any data center. This invariably implies that some form of metering must be installed and various metrics and key performance indicators carefully monitored. Unfortunately, the majority of data center metering systems are difficult to install or don't provide adequate, actionable, or business-level information. Strategia has addressed these difficulties and challenges and has developed an out-of-the-box solution, Papillon. In fact, your entire energy measurement system can be installed and operational within minutes or hours. It's a total software solution.
Papillon is unique and distinctive and is a total software agent-based solution. Here are some of its key characteristics. Installation is rapid and involves no downtime or retrofitting. It can be installed on all server types and operating systems. There is no impact on server performance or network traffic. Power and energy information at the rack and server levels is continuously measured in real time, but additionally, power is measured at the virtualized and application level. This opens up a whole opportunity of business-oriented tools for more informed business decisions and analysis. Simple incremental cost structure, a single license per server. Its open architecture and range of tools and reports makes it ideal for teaching purposes as well as being a full commercial tool. The design and operation of Papillon is that of a client-server architecture. Software power models of every server type are generated by Strategia and downloaded to a designated master server. These models are highly accurate and are based on standard performance statistics, observable from any operating system. Periodically, every server, via its agent, communicates performance data to the master. On reception of this data, the master uses the appropriate power model to compute the energy consumption of every server and virtual machine and application within them. This information is accessible in real time and is also stored in the Papillon database for future processing and reference. What can you do with the information that is generated? How does it make your data center or server room greener and more sustainable and more economic? Well, here's a list of just some of the actions open to you. As you can see, you have total visibility of energy consumption, whether it's at a physical or business service level. The IT manager and financial controller both can understand what is happening in the data center. There is no silo mentality. There's a shared view which all stakeholders can understand. The logic behind these options is quite straightforward. You can eliminate inefficiencies. Papillon will automatically identify underperforming servers and calculate the cost of their continued operation. Decommissioning these idle servers reduces energy consumption, lowers carbon emissions, and frees up rack space. These spare servers now reduce further capital expenditure. Cost centers and budgets can be established for users or services so that they can be managed within targets or allowances. Audits can be readily performed so that the effects or benefits of any newly introduced practices or procedures can be assessed in a timely fashion. Through reports, real-time analysis and astute monitoring, both users and providers of cloud services can acquire the information they need in the format and structure they require so as to maximize performance and minimize costs. Papillon gives easy access to all the energy data in the data center by utilizing the existing internet connectivity for communication. And regardless of server type or operating system, all the energy information is stored in a uniform format in the Papillon database. All Papillon tools, proprietary or otherwise, use this single database via its RESTful API library. StrategyR also believes that many new innovative solutions concerning sustainability in the data center are waiting to be created by the research and academic community. This innovation and creativity is facilitated by Papillon's extensive RESTful API library. Additional Java tools and apps can be rapidly developed. Here in UCD, some of our customized tools have been designed in a matter of weeks by our own students in a master's program. Education and training is equally as important as deploying the right technology, and together with the growing open source community, new ideas and solutions are being explored which are solving many of the energy challenges confronting the data center industry. You can see that Papillon enforces the principles of sustainability in the data center. There are reduced operational costs and carbon footprints. Computing is more environmentally aware and responsible, and there is more efficient, productive and economic use of IT resources. I hope this presentation has illustrated that a green, sustainable strategy in the data center makes good environmental and financial sense. And just as importantly, it is readily achievable once that commitment is made.